everybody. I wouldn't speak French, I'm sorry, because you'd suffer from that. I will speak today in English, so let's walk through the K2 stabilization journey. First of all, let's talk a little what the K2 is, then we'll walk through, Then we'll proceed to the quality-rated goals, which were posted by K2. And, in the end, we'll arrive how did we achieve those goals, or we are in process of achieving those, and how did we stabilize it. So, what is a K2? What do we mean when we say K2? Who knows? Right, so yeah, that's good because I actually have prepared a little thing to explain what the K2 is. It's refactoring. It's refactoring, you know. No, it's a mountain as well, but in our context, in context of Kotlin, it's just refactoring. Everybody did refactoring, right? You know, you have something that piled up, you have a lot of code, it works somehow, but you'd love to rewrite it so it works better, it's more performant, you know, so you're rewriting it. Let's take a look at a compiler. I wouldn't dive into the compiler theory today because we have a different topic, but what the compiler does, any compiler, it takes some source code, Kotlin code. It does some magic with that, and in the end we have target or machine code. Right, let's look a little bit deeper. So under the cover, we have a front end of this compiler and the backends. This is how the K1 compiler look like. Well, by the way, we call it K1 now. So the current compiler is K1, the next one is K2. And the current compiler, it has a front end. And by the way, this picture is from Sveta Isakova talk. You have a QR code here if you would like to watch it. I definitely recommend it to understand what the K2 is and why do we do that. So we have a front end. It does some magic with code, and it produces syntax tree of the code and some semantic info. Then it passes it to the backends. We all know that Kotlin is able to compile to JVM, to JS, to native. We have just talked about multi-platform. So what we did in K2, we have actually made it closer to the classic compiler theory. Now we have the front end, we have an intermediate representation, and only after that we have our specific backends. What does it mean? When we have some syntax tree produced by the compiler front end, we do some optimizations with this code. Those optimizations are common for each backend, be it JVM, JavaScript, or native. So why don't we just take it up and have an intermediate layer? That's what we did basically with K2, like with K1 and made it K2. Again, the details are in this talk. Don't hesitate to watch it after. So, the K2 is refactoring, and of course, when we do refactoring, we expect the better architecture, we expect performance, and in case of Kotlin, we also expect better language features. What does it mean? When we have a better architecture, it's easier for us to support new features because we have a more consistent logic among different backends, and as a result, we will have less corner cases. So this is really tangible result. And what is more, and what we wanted to be, K2 to be, it should be still good out Kotlin. It should be the same Kotlin. So this is how we come to what is not the K2 for us when we talk about Kotlin team. So we don't want it to be a conceptually different thing. We are not like some other programming languages, which release version 3, and it's completely different from version 2. No, we are not. We want it to be the same. And we don't want to bring any unbearable breaking changes. Instead, we see K2 as a really good thing when we want our users to profit from it and migrate easily. So, this is what K2 is. What are the quality-rated goals based on that? Of course, we want the K2 to be as stable as K1. And it should be a good old Kotlin we are used to. We want a clear migration. Like every major release of Kotlin, you have some breaking changes, but those are always listed, and we do our best to provide some migration. K2 or Kotlin 2.0 is just the very same case. And of course, we want improved performance because, well, we did refactoring, we want our price, right? And we want those results to be persistent. The K2 journey has begun in 2018. It's been like a really long journey, and well, we have written a lot of code. I will tell you today about it. And during this stabilization, we achieved something. We want to fix it, and we want it to be persistent. Good news, we have achieved it. So how did we do that? Right. Before I proceed with K2 stabilization, I want to make an important note. So we have this story with Solomon. One of the first times we met, he likes to tell it. He asked me, so how many QAs do you have in Kotlin? And I answered, well, 3.5, And well, he laughed a lot because, well, you have a huge Kotlin that was stable, Kotlin 1 point, I don't know, maybe 5, and we have 3.5 QAs there. Since that time, we grew a lot. Now we have 28 QAs and a team of 28 people. And we have different QAs. We have automation team. We have performance QAs. And of course, we have exploratory QAs, which is not the same thing as you actually usually have, like manual QA, which checks some cases. Here you have your language, and how would you test a compiler? You have to explore the things. You have to invent some things. So it's a bit different. All those QAs do their job daily, and today I wouldn't tell you about that, because today I'm gonna rather talk about special things we did for K2 to be more stable, while those folks still did their job. It's a baseline. So let's go to the special things. So we have written a half of compiler, and we haven't posted anything. Like we have released 1.9. Now we should release 2.0. And it should be stable as before. How do we do that? So where do we begin? Any ideas? You have rewritten a half of a compiler. What do you do? We? Right. Right. That's a really good idea. Yeah. Any more ideas? Sorry? Release an alpha version, yeah, that's also good. Ask your users to test it. Fuzzing, yeah, we have actually considered it as well, yeah.
Compile the compiler itself.
True, good. Any other?
Compile the compiler that you compiled.
Right, this is a good one. Cool, well, you have uncovered half of my talk, but anyway, I'll have to tell it to you, but yeah. The first thing actually is that that comes to a mind to an academic person is that you have a specification. You have a programming language, you have a specification. It's true, but in fact it's, you have documentation and you don't really maintain it sometimes. So we do have specification, but it's not exhaustive. And while we did use it, it's not 100% good. And we work on that, but we have to stabilize compiler. What do we do now? We compile code, of course. We begin with really simple things, hello world. Like you have a written compiler, it should work on something. Then we do recompile Kotlin project, that's right too. We have a lot of tests, of course. Do you have tests when you do refactoring? Right? Yes? Yeah? We have tests. We have compiled internal and external projects, indeed. So we have, in JetBrains, we do have a lot of, well, not a lot of, but several projects written in Kotlin, IntelliJ IDEA, UTrack, Toolbox Enterprise. So yeah, we did it. And we had alpha beta release, and we have a special dedicated group of EAP champions. I'll tell you what is that event. And of course, we have our partners who also use Kotlin, and we can ask them to compile it as well. So, Hello World. This is a Hello World version of our compiler team, and we have successfully compiled it in 2019. By that time, we have already written 20,000 of lines of code for K2. So how many lines of code you write to compile Hello World? By the way, now you can guess what is the number of lines of code now, because I'm gonna review it in the end, so you can guess, make a wish, Kotlin project. So this is what we call bootstrap test. We do also bootstrapping, and it has the very same idea. So we have K2 source code. We compile it with K1, we get K2 binary. Now we have a compiler binary with K2. We take K2 source code and compile it with this binary. This is K2 bootstrap binary. We have passed this test in 2021. By that time, we had 86,000 lines of code. Moving forward, yeah?
Is it the same byte-wise like compiler? Like if I do a diff of the K2 compiler compiled with K1,
Mm-hmm.
and the same.
It should be the same.
Like byte by byte?
I can't answer you that, but it should be the same. Right, so tests. You have written tests for some reason. Why don't we reuse it? And it's simple. You just run the existing test with K2, you compare the results, you are done, right? We have 250,000 of tests in compiler. And yes, of course, you run it with K2. We have compared results. We have fixed something. And well, among those tests, we have more than 1,000 kinds of error messages. And, it's not that simple always that you just fix the tests. Some errors are very specific and very important. Let's play another game. What is the worst error in the compiler? What would be the worst thing?
No pointer exception.
That's a good one. We have checked it, right? Sorry? Right, it's... can you expand it? Can you just describe the general case?
Anywhere where you don't know where to look in your code, know what
Mm-hmm.
the rest will be a missing error. Like it tells you that thing A is wrong, but thing A either doesn't exist or is not a problem at all, and you keep trying to fix A when it was problem L.
Okay, so you run your code, you got this sick fault, and you don't know what to do, right? So you have run your code, you got this sick fault, and you don't know what to do, right? And the code looks like it's really good. It doesn't have any error reports, so on and so forth. Okay, good. Yeah?
Infinite loop?
Sorry?
Infinite loop?
Infinite loop. Right, but how do you get there?
You have no error?
It's nothing.
I mean, I'm trying to get this, this golden phrase when you explain the use case. Like, for example, you have written some code and compiler reports an error message, and it's wrong message actually. It's a bug in compiler, or you have written your code, compiler compiles it, and then crashes in runtime, or you are compiling your code, and every time it produces a different result. Like, what would be the worst for you of those three, for example?
Introduces malware and
It's not what I proposed, but it's a good one.
Different results each time would be a nightmare.
And Heisenberg, where it's not always the same.
Right, okay. Sorry?
Being deterministic in its output.
Yeah, non-deterministic results. Okay, all right. Well, actually, our use a bit different. Of course, this is really nasty bug, and we do our best to avoid those. But we consider the worst case is that we have a false positive. When we have compiled our code, it didn't have any reports, and then it failed in runtime. And we call it diagnostic tests, such tests which check exactly those cases. And the problem is that there we've got some difference between K2 and K1. You see that we have like 8,000 of tests like this, and not all of those are equal between K2 and K1. So we had to walk through those results manually, compare those, and check if it's right or not, because of course while stabilizing K2, while rewriting the compiler, we've just fixed some bugs and some, unequal states in different backends. So yeah, it costs some work, and we were done with it. We have already passed it. We were done with it in 2022. By that time, we had 122 thousand lines of code. And in the middle of 2022, we have released JVM Alpha once we have almost stabilized it for such cases. Have you already reached some number you've guessed about the lines of code? No? Okay. Moving forward, internal and external projects. So, by that release of JVM Alpha, we have already compiled successfully IntelliJ community and uTrack. And a year later, we have released JVM beta, not KMP yet, and we had 140K of code, lines of code by that time. We have compiled more user projects, and it included IntelliJ Ultimate by that time. Yeah.
So, how do you figure that you correctly compiled IntelliJ Ultimate or Community? Because it's a very large project, and errors and miscompilation could happen in any tiny feature that you may not have checked.
It's painful. No, it really is. IntelliJ one of the biggest projects we have, and yeah, it's really hard to compile it, and it was even harder to migrate it. So yeah, but we did it. Yeah, we have also by that time we have compiled some Android-related projects, KSP-related projects, Spring-related. In general, we were building some system of user projects and internal projects which would cover almost every use case, like every popular use case we have among our users. Our goal was to cover specific combinations with popular frameworks, with popular tools, so we don't fail it. And of course, Android or Spring are among those. So, in the end of 2023, it's, the last release of K1, 1.9.20. We were able to compile 44 user projects, 150K lines of code, and it finally was KMP beta. And we have just skipped alpha, So we have compiled all of our internal libraries, right? No, not internal, Kotlin libraries. And we actually even have a Kotlin train. So, you take atomic foo, you take coroutines, you build cater on top, and we have compiled it as well. And what else? Of course, we have added KMP-related projects, scripting-related projects, Kotlin scripting, and Jetpack Compose. But by the time we didn't have Compose multi-platform compatible things, so we've just switched off Compose multi-platform in some projects, but we have turned it off on later on. And finally, now, RC1 this week. Ooh. We have compiled 50 projects, various projects, and 156 case lines of code. Among those, Toolbox Enterprise, one more huge project, yet cool one, and more KMP related and Compose multi-platform related. You may wonder why did it take so long, and why would you do that in the end, like you had your tests? Because Kotlin language is, any programming language is really complicated thing. It's almost like with a nature language. You can say anything with that. And you never know which phrase would break your mind. So we got to experiment with that. And if you ever tried to report a compiler issue, like anyone tried? You're our hero. So, of course, when you are trying to report a compiler issue, you have some code which breaks your project. And you wouldn't just go to utrack and create an issue like it doesn't work. Here is my project. Ciao. No, you are trying to figure out what are exactly those 2 lines of code which are freaking you out and break your project. So you are minimizing it, and if you have like 10 models in your project, you are taking it yourself, you're trying to realize what is that, localize it. And we did it 385 issues, like 385 times like that. Figure out, minimizing, localizing. And it's a lot of work, but it's really worth it. Because in the end, we've got not so many reports from our EP champions, but this is a bit later. Here is a graph to the 2nd April, because this is the last time I have updated it. It's about all the K2 related issues, and you can tell where we have released alpha, where we have released beta, and well, here we are now. It's more than 2,200 issues for K2 which are almost fixed. EAP champions. So we have compiled everything what we could, but our resources are limited. So we are asking our users to help us. Now we are kind of proud of it already, so we are ready to show it to the world. EAP champions, you have probably seen this post about EAP champions, and it says that it's a group of developers who work in a large-scale production-grade projects. Those are really champions because those people are ready to update their large-scale projects to the new version of Kotlin every time we release beta or RC. It's a close group. We were scoring it in the end of 2022, but probably we'll do it again soon. And it's really helpful. We are really thankful to those folks. You may have seen this section of our Kotlin 1.9.20 post, and we have it almost regularly. So, EAP champions are also explained. Now our partners, and I'm sorry, but I gotta tease you to the Kotlin Conf keynote because I'm not allowed to talk about it yet. But that is really great. You gotta see Kotlin Conf keynote. That's it. Let's see if we have met our quality goals. So we wanted K2 to be as stable as K1, and we have compiled almost everything we could, like really so many things in different directions, different perspectives. We are now eagerly asking our users, you, to try it out and report if there are some issues, because now it's really time. We are quite fast, quite close to a stable release now. And we wanted to go to out Kotlin we are used to, and we have used our tests, we have used those 50 user projects to check it out. We now got a migration guide. It's in the works, and we know some things which get to be migrated anyway, like it is every major version of Kotlin, but it shouldn't be that painful. We have improved performance. We actually had performance tests from the day one of this project, and we did some performance tests on the code of IntelliJ community, and it still runs and it's still good. And we've got persistent results because all those 50 projects which we have successfully compiled, now those are compiled with every build of Kotlin in our developer branch or in our release branch as well. And we also run tests on those projects. So if you ever had your tests in your projects, now you know that someone is really happy about it. That's it. Thank you. Questions? Yeah, so the question is, if you are a library author, and is it safe enough to compile your library with K2 RC1 now? So your users who use K1 wouldn't have problems, right? It should be safe now, yeah, it's actually the time. But if you have problems, you can reach me out in Slack, and yeah, I'll take care of this. Right. So we have compiled just 50 projects, user projects. And how can we be sure with such a small amount compared to how many Kotlin projects we actually have? How can we be sure that it's actually good enough? Right, so as I said, we had this idea to involve every significant technology which works with Kotlin or works in Kotlin in our projects, in the user projects we have selected for that. And those projects are not Hello World, those are real production projects. And yeah, our aim was to, first of all, cover different use cases, I mean, libraries or applications or frameworks on the one hand, and on the other hand, to cover different approaches. Like in KMP, you can share with your code with Cocoa Pods, you can share it in other ways, and we have covered those as well. So we've taken several different projects for each important use case we had in mind, and we've checked it out. We have found out that at some point we've stopped getting different errors, different problems. And when we have released it to the EAP champions and asked them to compile it, that wasn't much surprising. The results were not much surprising to us. So yeah, of course you can't be 100% sure. Never in the testing, you just do your best. All right. So the question is that I've talked about smooth migration from K1 to K2, and that, we are not like some other programming languages. And in that case, are there any plans for K3 which would actually break everything? So far it's rather a joke that we are going to have K3, and it's rather a nervous joke because we've almost done this huge project, and we do believe that even though it is demanding and it is hard, but it's what we wanted to build, and we really hope to continue this way without breaking everything at once. So the question is that if the Kotlin compiler is written in Kotlin, and at what point we were confident enough to write our compiler in Kotlin. I actually don't have exact answer because almost 7 years ago when I came to Kotlin, it was, I guess, already half written in Kotlin. So it's quite an old decision. I'm not aware of specific date. Yes. But the K2 compiler that we are publishing to the world now is built with K2 as well. Yeah, that's true. How long does it take to run all the Kotlin tests, Kotlin compiler tests in CI? Well, it's a good question. I actually don't know now. It shouldn't be. It shouldn't be more than 2 hours, I guess. But I don't know. Merci.